Hello everyone, in this video we are going to discuss the essay questions of the chapter Introduction, a very brief history of logic of block 2 of the paper Humanism and Logic of Srinarayana Guru Open University. So let's get started. First question, discuss the distinction between traditional logic and symbolic logic, highlighting their key differences and the advantages of symbolic logic in achieving clarity and precision in logical analysis. The distinction between traditional logic and symbolic logic lies in their approach to analyzing and representing logical arguments. Traditional logic, also known as Aristotelian logic, has its roots in the works of the ancient Greek philosopher Aristotle. The symbolic logic emerged as a more modern and formalized approach to logical reasoning. Traditional logic focuses on the analysis of categorical propositions and their relationship with syllogisms. It is primarily concerned with the study of the subject predicate structure of propositions and the validity of arguments based on their form. Aristotelian logic or traditional logic employs a limited set of symbols and relies heavily on natural language to express logical relationships. For example, the use of Venn diagrams and the traditional square of opposition are common tools in traditional logic. On the other hand, symbolic logic, also known as modern logic, takes a more abstract and formal approach to logical reasoning. It employs a comprehensive system of symbols and logical connectives to represent propositions, arguments, and their logical relationships. This symbolic representation allows for greater precision, clarity, and rigor in logical analysis. One of the key advantages of symbolic logic is its ability to avoid the ambiguities and vagueness inherent in natural language. By using well defined symbols and logical operations, symbolic logic eliminates the potential for misinterpretation and ensures that logical arguments are expressed with utmost clarity and precision. This is particularly important in fields such as mathematics, computer science, and formal reasoning, where ambiguity can lead to significant errors. Moreover, symbolic logic provides powerful tools and techniques for evaluating the validity of arguments. Methods such as truth tables, natural deduction systems, and proof techniques allow for a systematic and rigorous analysis of logical arguments. These techniques are particularly valuable in complex logical systems where traditional methods may become or insufficient. Another advantage of symbolic logic is its ability to handle more complex logical structures and higher order logics. Traditional logic is primarily focused on propositional logic and syllogistical reasoning, while symbolic logic can accommodate more advanced logical systems such as predicate logic, modal logic, and non classical logics. This versatility makes symbolic logic indispensable in various fields including artificial intelligence, computer science, and formal verification. Despite its advantages, symbolic logic is not necessarily a replacement for traditional logic. Both approaches have their merits and applications. Traditional logic remains valuable in teaching the foundations of logical reasoning and in understanding the historical development of logical thought. Additionally, it can be more accessible and intuitive for non specialties, making it useful in everyday reasoning and communication. In summary, while traditional logic laid the groundwork for logical reasoning, symbolic logic emerged as a more formalized and rigorous approach to logical analysis. Its uses of precise symbolic notation, powerful analytical techniques, and ability to handle complex logical structures make symbolic logic an invaluable tool in achieving clarity and precision in logical reasoning, particularly in fields that demand formal and unambiguous logical analysis. Second question, explain the concepts of deductive reasoning, inductive reasoning, and abductive reasoning. Discuss the differences, strengths, and applications in various fields, providing relevant examples. Deductive reasoning, inductive reasoning, and abductive reasoning are three distinct forms of logical inference that play crucial roles in various fields of study and everyday reasoning. Each approach has its unique characteristics, strengths, and applications. Deductive reasoning. Deductive reasoning is a form of logical inference where the conclusion follows necessarily from the premises. If the premises are true and the reason is valid, the conclusion must be true. Deductive arguments are structured in a way that the truth of the premises guarantees the truth of the conclusion. This type of reasoning is often associated with certainty and logical necessity. Example, all humans are mortal. Socrates is a human, therefore, Socrates is mortal. Deductive reasoning is widely used in fields such as mathematics, logic, and computer programming, where certainty and rigor are essential. It is also crucial in legal reasoning, where arguments and conclusions must be logically derived from established laws and precedents. Inductive reasoning. Inductive reasoning involves drawing conclusions based on observations, patterns, or empirical evidence. In inductive arguments, the conclusion is probable or likely but not necessarily certain based on the premises or evidence presented. Inductive reasoning moves from specific instances or observations to general principles or theories. Example, the sun has risen every morning for the past billion days. Therefore, the sun will rise tomorrow. Inductive reasoning is essential in scientific research where hypotheses are formulated based on observations and experiments, and theories are developed through the accumulation of evidence. It is also widely used in fields such as statistics, machine learning, and data analysis, where patterns and generalizations are drawn from data sets. Abductive reasoning. Abductive reasoning, also known as inference to the best explanation, involves forming a conclusion that provides the most plausible or likely explanation for a given set of observations or facts. It is a form of reasoning that moves from observations to the most probable explanation or hypothesis. Example, you notice wet footprints on the floor and the window are open. The best explanation or abductive reasoning is that it has been raining outside. Abductive reasoning is commonly used in the fields such as medical diagnosis, where doctors observe symptoms and propose the most likely underlying cause or disease. It is also employed in fields like forensics, where investigators analyze evidence and develop hypotheses about what might have occurred. differences, and strengths. The key differences between these reasoning approaches lie in the nature of the inference and the certainty associated with the conclusion. Deductive reasoning provides certainty and logical necessity, but it relies on the truth of the premises. Inductive reasoning allows for generalizations and predications based on evidence, but the conclusions are probably rather than certain. Abductive reasoning, on the other hand, aims to find the most plausible explanation for a set of observations, but the conclusion is not guaranteed to be true. Each form of reasoning has its strengths and applications. Deductive reasoning is crucial for establishing logically certain conclusions in the fields like mathematics and logic. Inductive reasoning is essential for scientific inquiry, theory development, and pattern recognition. Abductive reasoning is valuable in fields where explanatory hypotheses are needed, such as medical diagnosis, forensics, and scientific discovery. In practice, these forms of reasoning are often used in combination or complement each other. Scientists may use inductive reasoning to formulate hypotheses based on observations and then employ deductive reasoning to test and validate those hypotheses. Abductive reasoning can provide initial explanatory hypotheses which are then further investigated through inductive and deductive methods. By understanding and applying the appropriate form of reasoning for a given context, we can enhance our ability to draw valid conclusions, make informed decisions, and advance knowledge in various fields of study and practical applications. These are some of the important essay questions of this chapter. Thank you for listening.